Hello everyone. Today you will carry out the static analysis of a crane using truss members simulations with Solidworks. The main outcomes of this simulation are to calculate the maximum deflection of these problems and the factor of safety for any member of this crane, and also learn how we can convert a skeletal model to a structure profile using SolidWorks weldment modules. We will also calculate the stresses as well as forces in a specific structure member of this crane. So let's start our simulation study now. So first of all, we will make the line diagrams of this crane. So we have created the sketch of a crane like this. You can download this sketch from our video description link. After that, you will define the structural members using SolidWorks weldment tool. So click on the SolidWorks and then click on the structure members, and from the standard select the ISO, and from the type here is the pipe, this is the size of the pipe, and click on the group. Here we will define the different groups of structure members. So start for first group, click start from here and select in this way. So we have created the first group in this patterns. Now click on the new group. Now we will create the outer, select the outer elements of this crane starting from here and select in this way. So if you are new to my channel, please subscribe, and if you have any queries, you can ask your questions in comment sections. We also offer 3D modeling as well as simulation services if you want to avail. So in this way, we have selected the second group. After that, make a new group and select this one. So this is the third group. Again, click on the new group and select these two members. That is the fourth group. Again, go to here, then select this member, this one, sorry, and this one. Again, then select this last one. Click OK. The diameter of the outer this pipe is, that is the weldment profile, is 33.77. We will change it. So we will change the profile of this all structure members. So click on the pipe and go to the sketch, then edit the sketch. You can see the outer dia is 33.7 and inner is 25.7. We will make this outer dia to 200 millimeter and the inner one to 80 millimeter. Press F. So you can see the size of pipe has been changed. Exit from sketch now. Then bring your front view. So in this way we have increased or changed the profile of all structures. So it's time to start your simulation study now. So go to the SolidWorks add-ins and from here select the SolidWorks Simulation Premium and wait until the simulation tab appears. Now click on the simulations, click on the new study and from the general simulation type select the static, give the specific name to this study, that is the crane study. Okay. After that, we will assign the material to all structural members. So just right click on the cranes, go to the apply, edit material and apply alloy steel. Please note the yield strength as well as elastic modulus of this alloy steel is here. Apply, close. And now ensure we will convert all the structure members to truss. Just expand this folder, expand the cut list folder. You can see that this structure member has been treated as a beam. So go to edit definitions, then select the truss from the type. You have to repeat this for all members of this crane. Again, select all these, go to edit definitions. Okay. You can see symbol has been changed to the truss symbols. So we have converted all beams into truss as you can see here. Now our next step is to apply the supports. We will apply the three types of the supports or fixtures. First of all, please note that we are evaluating the simulations by considering this truss or a crane as a 2D planar truss. If when we conduct the simulations of a 2D planar, that means that there is no movement in its z directions or your normal to your screen. So first of all, we will apply a support to all these joints in the z directions so that they cannot move in z directions and we can treat this problem as a 2D planar truss. After that, our next support will be on this joint. This joint is fixed for all degree of freedoms. And after that, this joint has a translational supports or immovable supports or roller supports. That means it can only move, it can only fixed in x direction as well as in the y directions. So go to the fixtures, select the fixed geometry, use the reference geometry. Clear selections, select all these joints. Now click on the reference or directions and select the front plane. Then make zero movement in the z directions. So click here, change the symbol size, increase the symbol size of support to 200. You can see a support has been applied in the z directions. Okay. Similarly, you will apply a fixed support on this joint. Right click on the fixture, fixed geometry, and from fixed geometry type select this joint, change its symbol size and color to blue one and also change the size to 200. So this is a fixed joint that all degree of freedom has been fixed to. And after that, you will apply immovable support on the this joint. So select the immovable and click change the symbol size and the color to red one and change the size of the symbol to 200. So we have applied three types of supports. First is the fix. We have fixed all number of joints in these directions, and we have applied a fixed support to this joint, and we have applied a immovable support to this joint. You can see. So next our step is to apply the supports or loads. So we will apply a load on this joint and in this joint in the y directions. So go to the loads and select the force. Now select the joint, select this one, and from the direction select the front plane and click the y directions, reverse the directions and change the force, that is 150,000 Newton. Change the symbol size. Now copy this loading conditions, copy and paste it again. Now edit definitions and from here clear selections, then select this joint and apply and change the value to 100, 200, 200,000, 200,000, 103 Newton. Force has been applied on this joint. So it's time to run your study. So our solution has been running. Wait until your solution converged. Sorry, we will change the load to 1500 kilonewton and 2000 kilonewtons. So go to the Solidworks and change this value to 1500 kilonewton and this value to 2000 kilonewton. Okay, then run your simulation study again. So our study has been completed now. Click on the front view. First of all, we will check the maximum deformations. You can see that the maximum deformation is 40.7 millimeter. If we go to edit definitions and from the chart options, select the maximum deformations that occur at this joint is 40.7 millimeters. We can also animate the deformation behaviors. Will be like this. Please note that there is no movement in the z directions. You can see here because we are defining it a 2D planar truss. So our next step is to evaluate the forces as well as stresses in this structure members in this one. So go to the results, right click here and list the beam force. Here you can see the two options. First is force and other is stress. So click on the force and OK. So here are the forces for all members. Click on the show only endpoints. Just you can see, just click this arrow. At this point, this is the this one. Again, carry on clicking so that this point appears, this member appears. Yes, this is the members. You can see the axial forces on this members is this one. That is 600, 660 kilonewtons in tension and the compressions. This joint is in compression, this end is in the compressions. Similarly, we can evaluate the stresses. Again, go to the results. Result the beam force. From here, select the stresses. Okay. Then click on the show only. Show only and endpoints. Again, click here arrows in order to select your members. So you can see now the stress in these members. And if we check the units into SI units, is the 2.5 25,000 kilonewton per meter square. You can see stress is on these members. Okay, we can also evaluate the factor of safety for all members. You can see the factor of safety, minimum factor of safety is 3.7. That occurs on all these points. We can also calculate factor of safety for any specific members. For example, if we want to factor of safety for this one, go to edit definitions, click on the selected bodies, click this one. So this is the factor of safety 2.6, EQ 15, very much higher. If we want to click for here, go to edit definitions, click this one. So this is the factor of safety for this one. Again, go to the edit definitions, select the alls. So this is the factor of safety, minimum factor of safety. So we have, if we summarize today's topic, you have learned a lot. You have learned how you can define a line diagrams. Then I converted this skeletal or sketch into a structure member of the cranes, and when also we used weldment tools to change the profile of the cranes. Beside this, we also learned how you can treat each member as a truss and how to apply the supports in z directions and how to apply a fixed support as well as a translational supports. Then evaluates the stresses, apply the loads on the joints using reference geometry. Then evaluates the stresses at a specific member as well as forces on a specific members, then factor of safety. So I hope you enjoyed this study. If you have any query, you can ask me in questions or comment box. Thank you for watching.